So that's what your foldable looks like when you fold it. And we're going to start in the upper left corner. You have a few words to put in. One of them is median. A median of a triangle is the segment from the vertex to the midpoint of the opposite side. Segment from the vertex to the midpoint of the opposite side. Oops, I flipped it. I didn't mean to. I apologize. Okay. So, the three medians of a triangle, guess what? They're concurrent. They all meet at one point. Just like they have in the past with the circumcenter and the incenter. The angle bisectors and the perpendicular bisectors. We call this point of concurrency the centroid. Okay? So we found the midpoints of the sides, and we drew a segment from the opposite vertex to that midpoint 3 times over. And point P is called the centroid. And the centroid always has to be inside the triangle. And there's also a cool thing. E is a midpoint of B and C, splits it evenly. F is a midpoint of A and C, and D is a midpoint of B and A. Okay, so if we go from B to F, and from A to E, and from C to D, they'll all meet at one point, and that point is called the centroid. Nope, sorry. This guy is the centroid. Okay, where they all meet. And they always meet inside the triangle. The cool thing about the centroid is it's the center of gravity. Okay, so if I would cut that triangle out and I would set the triangle on top of my pencil at the centroid, that triangle would balance. Okay, it wouldn't fly off, it wouldn't fall off. Okay, it's the center of gravity. All right, so the theorem about the centroid is that it is 2/3 of the way of the distance from each vertex to the opposite side. The centroid is 2/3 of the distance from the vertex to the opposite side. How many people like dealing with a fraction like 2/3? Okay, we got one person. Okay, want me to show you a shortcut? Okay. If this is 1/3 and this is 2/3, then this part is double that part. Does that make sense? If this is 2/3 of the way there, I can split it in half. If this is x, from the vertex to that centroid is going to be 2x. It's going to be twice as big. Okay? Yeah, cut the bigger line in half, and now you know all three. Does that make sense? All right, so let's look at it. Don't look at all of this. Don't write all of this down. Let's look at it in practical application. Okay? So here's our example. Okay? I'm sorry. The other blank was the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay? All right, so far so good? The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay? Those are your two keywords. All right, so here we go. They told us that Q is the centroid. Okay? Q is the centroid. V is a midpoint. W is a midpoint. U is a midpoint. Q is the centroid. Bless you. So if the distance between V and Q is 5, what will the distance between Q and R be? 10. Okay? Because we doubled this short distance to get the long distance. Okay? And how long would VR be then? The distance between V and R. 5 plus 10, 15. You see how the math isn't hard? It's all the vocab. Yeah, and the sooner you get the vocab down, the sooner this makes sense. Okay? But otherwise, I'm up here speaking a foreign language, so you've got to study that vocab. Okay? Now, let's try it another way. Okay? What if I told you that the distance between S and W is 12? Graydon, stop. Okay? If I told you the distance between S and W is 12, could we figure out what the distance between Q and W is? Yeah. So 12 divided by the 3 parts, right, is 4. So this portion would be 4, and this portion would be 8, because 4 plus 8 gives me 12. Okay? So if you have the distance between a point and the midpoint of the opposite side, divide it by 3 to find the small piece, and double that to find the large piece. Those aren't hard, right? SW, if SW was 12, then QW would be 4, and SQ would be 8. Okay. Questions on this slide? Okay. All right, next one. So here's where we turn it to the coordinate geometry piece. And you can do this if you think about it. Okay? We have a triangle that has points at 0, 4, -4, 2, and 7, 1. And we want to figure out where the centroid is. Okay? What's the first thing we have to do? Maya. Find the midpoint. Okay? So pick a segment. Which segment are we finding the midpoint of? Joseph, you need to move to your side seat, please, sir. Okay? So we're doing CB. Okay? C to B, let's find the midpoint between these two sides. When we find the midpoint, we add the x's, divide by 2. Add the y's, divide by 2. Okay? -4 plus 7 is how much? 3. 3 divided by 2 is 1.5. Then we take the -2 plus 1 and divide it by 2. -2 plus 1 is -1 divided by 2 is -1/2. Okay? So we have a midpoint between B and C at 1.5, -1/2. That's that guy. What do I do with that midpoint? It needs to be connected to the vertex of the vertex to the midpoint of the opposite side, right? So we come from this side and we go to the opposite vertex, and that's one of our lines. Okay? So we only had to find a midpoint and connect the dots, right? Now let's do it again. Okay? Which other one do you want to find the midpoint of? AB. So the midpoint between A and B Okay? Midpoint of AC means that we're taking 0, 4, and 7, 1, and we're going to add the x's, divide by 2. Add the y's, divide by 2. 7 divided by 2 is 3.5. 5 divided by 2 is 2.5. So we find a midpoint at 3.5, 2.5. 3.5 over 2.5 up. What do we do with that midpoint? Connect it to the opposite angle, the opposite point, right? Okay, from this side to the opposite vertex. And then you could do the third one with C, but I'm not going to make you do that if you don't want to. 2 is enough. The centroid is 1, 1. That wasn't so hard, right? We've been doing midpoints all year long since chapter 1. Okay, so that's not hard. I'm happy if you find 2. And use a straight edge. Use a ruler, use your planner, something to give nice straight lines so you can tell where those cross. Absolutely. We found the midpoint of this side and the midpoint of this side, right? And we connected them to their opposite vertices, and where they crossed is our centroid. Okay? If we would find the midpoint of this third side and connect it to its opposite vertex, it's also going to go through that same point. Okay, Maya. Absolutely. Okay, my daughter figured this out. She didn't bother with midpoints. She had a ruler, and she said, guess what? If I measure this, and it happens to be 30 inches, then I'm going to go 15 inches over and put a dot. And if I measure this one, and it happens to be 24 inches, I'm going to go 12 inches and put a dot. No. I want you to know what they are, right? It's not the accurate geometric way to do it, because the proper way would be to find the midpoints. But you still use a straight edge, okay? In geometry, you don't really have rulers. You have straight edges. They don't normally have numbers on them. They're just something to make a straight line with in true geometry. If you bring your ruler, that's fine. I'm not providing them. I don't have enough. They disappear. No. No. Even though the distance from your knuckle to your tip of your finger is typically 1 inch. 2 inches, 3 inches, it's a general rule. So that's all we're looking for is a centroid there. Okay, you got to show me midpoint and connection. I'm sorry. So to get that number, we found the midpoint here, connected, found the midpoint here and connected, and where they crossed is our centroid. Okay, so if I would cut this triangle out and put it on a pencil where that dot is, it would stay. It wouldn't fall. The center of gravity for that particular triangle. Okay, so far so good. Okay. So the next one we're talking about is the altitude. Okay, the altitude of a triangle. Remember, we're talking about height here, right? And you've been using altitude of triangles for a long time now. Whenever you had to find the area of a triangle, base times height, right? So the altitude of a triangle, keyword in your notes, is a perpendicular segment the other word, the other blank in your notes. From a vertex to the opposite side, or to a line that contains the opposite side. Okay, so this is an altitude of triangle PQR when PQR is an acute triangle. When it is an obtuse triangle, we can't go from the vertex to the opposite side unless we extend that opposite side. Does that make sense? Okay. So sometimes the altitude will be outside of the triangle, and we have to extend that leg. Braden, have a seat, please. Put your phone down. So, okay, these are blanks. The lines that contain the altitudes of a triangle are going to be concurrent. Okay? Their point of concurrency is the orthocenter. So, the orthocenter can be inside of the triangle if it's acute. It can be on the triangle, on the hypotenuse, if it's a right triangle. And it can be outside the triangle if the triangle is obtuse. Okay? So, let's find the orthocenter of this triangle. You'll be okay. Okay? So how are we going to find the orthocenter? Perpendicular segments. Which one's the easiest to... Yep, from the opposite side to the... Okay? Yeah, let's do DF. Okay? So everyone see that this is the easy one? Horizontal lines have perpendicular vertical lines, right? All right, so let's extend DF because from E to DF I have to go this way, don't I? Does everyone see that that will make a right angle? Okay, because this is an obtuse triangle, and so if I tried to make a line perpendicular to this one, it's not gonna hit it unless I extend that line. Okay, so we have one segment. Now we just need to find one more and find out where they cross. Okay, so that's the right angle. That's one of them. Which other one do we want to find? Okay, so let me back up and show again why I did it. Okay, you all said that horizontal lines are easy to find perpendiculars to, right? Because vertical lines are perpendicular to horizontal. So we always want to pick a horizontal or vertical if we have it to start with. Okay, so now if I'm trying to go from E to the opposite side, perpendicular to it, I have to go straight up and down because this one goes side to side. And because it's obtuse, because this is a big angle, it's an angle bigger than 90, I have to actually move this out, just like they did over here. See how they did this? They said, guess what? If it's here, an obtuse triangle, we have to sometimes extend that triangle, okay, in order to get a perpendicular to it. Okay? Those are just the extensions. They had to make them longer. And so this is the guy that's outside. That's the... All right, so when it's not acute, it's going to be outside. Nope. The orthocenter doesn't always have to be inside the triangle. The centroid has to be inside along with the incenter. The centroid is made by the medians, right? And the orthocenter is made by the altitudes. Altitudes are perpendicular from this to the other side. Okay? So we've got one. Now let's pick another one. All right, let's do FE. Right, we can't just go, we don't have a vertical or a horizontal, right? But look at this guy. What's his slope? From here up. Are we going uphill or downhill? Uphill. So we know we have a positive slope, right? And we're rising 1, 2, and running 1, 2. Rising 1, running 1, rising 1, running 1, rising 1, running 1. Everybody see that? Or we could say we went up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5, 6, 7, 8. Okay? So what's its slope? 8 over 8, which reduces to 1 over 1. So this one has a slope of 1. What's the perpendicular going to be? -1. We flip it and we change the sign. Okay? So which point is opposite this segment? D. D is far away, right? It doesn't make the segment. Sorry, which one is opposite EF, segment EF? Okay? So D is opposite, right? So from D, we want to go down 1, over 1. Down 1, over 1. Down 1, over 1. Right? This one went up 1 over 1, up 1 over 1, up 1 over 1. Positive 1 for the slope. So from D, we want to go down 1 over 1, a -1 for the slope. Okay? So here's my perpendicular, right? So if I want to make it meet that other line, which way do I need to go? All the way up, right? That's the orthocenter. It's outside when this was an obtuse triangle to begin with. Red line meets the blue. Okay? And so that's the point -4, 10, isn't it? Okay? So -4, 10. Yep. We could do the same thing with one more, right? We could say, hey, let's find this one, right? But it's rising 1, 2, and running 1. So if it's rising 2 and running 1, then we need to go down 1 and over 2, right? Negative reciprocal. Okay? It is. It is confusing. There's a lot of information. Okay? Okay. So let me give you the assignment. Okay? And we can go over this last example if we have time. Okay? Don't have time? We got 3 minutes. So your assignment's straight from your green sheet, right? Okay? Assignment's straight from the green sheet. And anybody want to see that last one? Gonna hold off. Okay.